So if your bottle turns to red, what does it mean?
I don't know, let's see. Let's see what the bottle turns into first. Go ahead.
Give it a good shake, shake.
Shake, shake, shake.
Woo.
Shake, shake, shake. Shake, shake, shake. Shake, shake, shake. All right, and then off. All right, what color do we see here? Blue. Blue. What do we think this young man's future holds? Hey, police officer? Uniform in blue? Yeah.
Dalton.
What about over here
How
now?
about here?
His turn to like a blood
Let
red.
me see that.
He's a vampire.
Maybe he'll be a winemaker.
Maybe wine taster?
Have you been lying to us?
Wine taster, firefighter?
Yeah.
Yeah?
Blood doctor.
A blood doctor, good. Doctor, good choice.
Thank you.
Thank you, guys.
Thank you. Oh, look! Back to normal. Ooh, this one will also. Alright. See, it's not dark. It's not that dark red anymore, right? Neither is this one blue anymore. Color bottle. Thank you.
Alrighty, so earlier on we made some milk, water, cherry, chocolate milk. Honestly, who drinks that at a party?
I don't.
We want soda. And since Peyton's a birthday girl, she gets to decide what kind of drink she wants.
I like a classic Coke.
Okay.
Coca-Cola. It's all good.
So we're gonna make some Coca-Cola to celebrate Peyton's birthday. So, you ready?
That's like a witch.
Alright, 2 Cokes for me.
And 2 waters. Ready? Hey, thanks guys.
You don't want one?
Weird instant and the first one, he just... The first one, like... No, set it to loading and then load it.
That's a good one.
It looked legit.
It seems I've lost the microphone again, so you guys are gonna have to listen up. I have a jar here. I personally am not that athletic, I'm not that great at running, so when I try to catch fireflies, I trip, I fall, I'm not that fast. So what I'm gonna do is I'm gonna make a firefly. You're a scientist, you don't have to be athletic, you can just make stuff.
Gatorade to the next.
See, now I don't have to go to the store to buy glow sticks either.
That's toxic. Very. I would assume.
What did you just see? What is it called?
Chemical reaction.
Glowing reaction. Yeah, does anybody else know what it is? It's called chemiluminescence. It means the energy from the chemicals have enough energy to go into a molecule and make it luminesce. Can anybody think of an application of this? Did you ever go to a carnival and get one of those necklaces that glows in the dark? Did you ever go to the hardware store and buy these glow sticks? Do you know what they were developed for? For pilots that have to bail out in the ocean. If you get into salt water, no flashlight will work. So the US government asked, we need a device that will stay forever. And all you really do is the pilot just takes that tube and you're told to hit it like this. You release a chemical and it will glow that green color, which is visible in the night on an ocean for more than 20 miles. So imagine if you're the poor pilot stuck in the middle of the Pacific Ocean. In airplanes, you can hear planes all the way around, but they can't see you. You can hold this thing up and those things will glow for close to 3/4 of an hour and can be seen from a distance of almost 20 miles. They're included in all kinds of emergency packs now for the military, civilian Air Corps, and everything. So all this fun stuff that we're seeing really has very important applications, and that's the reason why the government is so concerned about, they even give it an acronym now, they call it STEM. What's STEM? And I ain't talking about a plant. Science, technology, engineering, and mathematics. That's where the business comes from, the whole economy.
Okay, ladies and gentlemen, this next demonstration is called Fireworks Colors. And so have you ever watched a fireworks show? Yes. On TV maybe? YouTube? Have you seen a fireworks show, folks? Yes. Okay, so one of the nice things about fireworks shows, obviously, are the different colors that you get out of the fireworks. And the way you get different colors out of the fireworks is by placing a different metallic salt in with the gunpowder. So I'm basically doing a variation of that here. Each of these compounds that I'm pouring into these Petri dishes contains a different metallic salt. Our first one is barium, calcium, lithium. I know that was copper. This is a sodium salt. And this one's strontium. And this one doesn't want to come out. Get a little bit there. That's the lithium. It's a troublesome one. And in these Petri dishes, I have placed a flammable liquid. So what I'm going to do is light on fire. And the heat from the fire is going to be absorbed or gained by the metallic salts. And what this will do is get the electrons in the metallic salts to jump up and down. Some of you may have heard of the excited state. So we're going to excite some electrons. Now, that's not very exciting. What's exciting is when the electrons return down to ground states from higher energy levels. When they do that, they release the energy, the heat energy absorbed by the flame in the form of colored light. I hate this. It takes a little while for them to warm up. And in a little bit, we'll have different colored fireworks. Now, ladies and gentlemen, fireworks colors. And they will develop a little bit more. This was nice. In fact, you may have seen this color. Being in New York City, you've probably seen cars that have broken down on the side of the road from time to time. And if the police come, one of the things they'll do is they'll put a roadside flare, basically like a little red fire, a little behind the car to alert people that there's an emergency ahead and to steer clear and to slow down. And that roadside flare contains a lithium salt. That's what gets it to burn red. So, ladies and gentlemen, fireworks colors.
I like how you think. Fireworks.
You like fire?
I do.
You like color?
So what do you say we make a firework here in this building right now? Because to make a firework, it's got to go where to be a firework, ladies and gentlemen? Up. We have to get it there somehow. So what I think we should do is we should use some of that special liquid he has in there to light it as a fuel and create a little propellant. So we'll use some of that liquid and we'll trap it inside a little container and light it with a spark. Oh no, really, a spark. No, really, a spark. You have a spark? You give me a defective popper. Trust me, it pops. And we'll put it on this popper over here now. So we'll take some liquid that he has over there. I don't know. We'll put it up here. We'll trap it here for a second with a countdown from 5. No, really, from 5.
5, 4, 2, 1. Oh, that landed? I was gonna say.
Almost landed. Did anybody see the color that was in here? What color was it? What color? Red. So it would be what salt? Lithium, I heard it. Congratulations. Fireworks in the building.
You ready for the next one? I'm gonna learn a little bit about acids and bases. Anybody heard of acids and bases? Yes? What I have here is a base. I'm gonna put it in some water here. Now, tell me, how do I know this is a base? Anybody? What can I do? I can check the pH, exactly. So I'm gonna do that. I can do that with a pH meter, or I can have a little fun, and I can use what's called a universal indicator. What do you think I'm gonna see if it's a base?